Welcome everyone, or welcome back if you've been to office hours before. This is our third Gremlin office hours, how to test your systems for scalability and redundancy with fault injection. So quick notes before we get started. This is an interactive webinar. We want to hear from you as much as you want to hear from us. So if you have questions, please feel free to enter them into the Q&A panel or just hang out in the chat channel, say hi, let us know where you're coming from and what you hope to get out of this presentation. Afterwards, after we do the quick presentation, you'll be able to unmute yourself. So if you want to ask a question out loud or offer any additional thoughts or your own experiences, or just to say hi, feel free to do so. This webinar will be recorded and the recording will be made available afterwards, so you can rewatch it if you need to leave early. And also, this is a monthly series. You can see and sign up for future sessions by going to gremlin.com/office hours. We'll post them several months in advance, so you can see what's coming up and what looks interesting to you and sign up there. And also, if you don't know me, I'm Andre Newman, a senior reliability specialist here at Gremlin, and I'm joined by Dan Murray, senior solutions architect, also here at Gremlin. We're here to answer your questions. So again, if you have any, please feel free to submit them. So a quick look at the agenda for today. I'll start with a short presentation introducing the idea of fault injection. You all are customers or have used Gremlin before, so chances are you already know what fault injection is, but this is just sort of a level setting recap of it. I'll talk about considerations for scalability and redundancy, what they mean, and what you need to think about when you're implementing them. We'll talk about how to actually run resource and network experiments in Gremlin to be able to test for scalability and redundancy. Dan will walk us through a demo showing that on AWS. And then we'll end with a Q&A where you can, again, ask your questions and we'll answer them. So I always like to start off each of these sessions with some goals. First of all, we want to be able to have an auto-scaling group where we can verify that it will scale by adding new nodes when we hit resource thresholds. This is going to test our ability to scale under high demand. Second, for redundancy, we want to make sure that even if one of our nodes fails, we can continue serving traffic and continue saving customers despite that. And we also want to know what your goals are, right? So if you have any specific goals that you've worked on for redundancy or scalability, any challenges you've overcame or ways that you've implemented it in your own organization, definitely let us know. We want to hear about that. All right, so let's start with the basics. What is fault injection? So in summary, fault injection is a technique for creating controlled failure in a computing environment. I put controlled in bold for a very important reason. Technically, you can walk up to a server and pull the plug, and that's creating failure, right, in a sense. But of course, that's chaotic, that's hard to recover from, and a lot of people would be very mad at you for doing that. Controlled means that the fault we inject can be stopped at any time, has no direct impact outside of the systems that we specifically target, and it don't make modifications, permanent modifications rather, to the systems that we're testing. So instead of going to your data center and pulling the plug on the server, we could do something like issue a restart command, or better yet, issue a command to drop all network traffic to and from the server to make it seem as if it was offline while still retaining a way to pull it back. And the screenshot I have is something that you've all probably seen before if you've ever ran a CPU attack before, just showing how this looks in the Gremlin web UI and how the impact can be just immediately reverted once the attack is finished. So we'll kick it off by looking at scalability. Of course, the main goal of scalable systems is to automatically increase or decrease capacity to meet changes in demand. Excuse me. If we have, let's say, a growing customer base that's putting more load on our systems, we want to be able to dynamically add enough capacity to be able to support that. And on the flip side, if this load decreases, we want to be able to pull capacity out of our environment so we're not paying for resources that we're not using. Typically, scalability is based off of one or two metrics, CPU usage or memory usage. You can, of course, use other metrics. Ideally, you'll use ones that are specific to your service or your application, but these are the easiest to understand and typically the first ones that folks implement. The way you can approach this is, once you have these metrics in place, use Gremlin's CPU or memory experiments to simulate this high demand until you reach your scaling threshold. Then once that threshold is reached, you can, of course, monitor your systems or your cluster to make sure that it scales as expected and those new nodes get added. So how this would work in practice is, first, you would create a cluster with that automatic scaling built in. We use AWS a lot for our example, since that's what most of our customers use and are familiar with, but the same concept work for any cloud provider. Basically, you'd have your cluster with an auto-scaling system or ASG in place and have some kind of load balancer ahead of it to route traffic between nodes or even between clusters if you have multiple. So traffic comes in from the internet, hits that elastic load balancer. That load balancer knows which of the nodes in our cluster are healthy and able to respond to traffic and routes traffic accordingly. Next thing is that we would configure this ASG to scale based on a metric. Again, like the cluster's average CPU usage or average memory usage. We want to set it to something high so that a little bump in traffic doesn't trigger scaling, but we still want to leave a bit of overhead because scaling isn't instantaneous. You'll need time to spin up those new nodes and actually connect them to your load balancer. So you want to find that balance of having enough overhead to leave your systems enough time to maintain the load while the new systems spin up, but without being so low that they scale without actually needing that new capacity. We use 80% as a common example, but your mileage might vary. Next, start up that CPU experiment and set it to your threshold or even a little bit over. You'll see CPU usage shoot up. Amazon or whichever cloud provider you're using will detect this, and if it meets your threshold, you should see a new instance start spinning up. Pretty easy, pretty straightforward test with pretty immediate results. Once this instance joins the cluster, its CPU gets averaged in, and the cluster-wide CPU usage drops back down below the threshold, which brings you back to that safe level and prevents you from having this like runaway cascading scaling effect. And just jumping back to that 80% number again, this isn't universal. This isn't like a absolute recommendation. Your level might vary based off of your service, the type of demand you get, how much that demand actually affects CPU usage, and how quickly that demand increases or decreases. And of course, how much you're willing to spend on cloud infrastructure cost, because cost is always a big factor. I'd recommend checking with your cloud provider's best practices, like AWS's well-architected framework, and see what it recommends, and of course, do some testing to find your own thresholds that work best for you. And again, I should have clicked on the step before. Check for those new nodes after you run that gremlin experiment. So jumping over to redundancy, redundancy is a little different, but a lot of the concepts are actually the same or can be shared. The main difference is that instead of adding or removing capacity, we want to make sure that we can keep our service up and running, even if something disastrous happens, like the server room floods or a data center loses power. And yes, these things actually do happen, even to huge, sophisticated cloud providers. The good thing is that most providers already give you the tools to add redundancy yourself, like being able to deploy auto-scaling groups across multiple availability zones and being able to route traffic between those zones using distributed service like Route 53 or Amazon ELB. Now, more advanced redundancy, like data replication, takes a little more know-how and frankly goes beyond the scope of this session. But again, it's something that you can do with the help of your cloud provider. So as far as testing redundancy goes, there are a couple of different approaches. One is you can run a shutdown experiment. This does exactly what it sounds like, just turns off a node or issues a reboot command. If you've ever heard or used Chaos Monkey, this probably sounds very familiar. This is actually the technique that Netflix used when creating Chaos Monkey 10, 12, however many years ago it was when that first came out. The way it worked was they would deploy it, they'd set a time for it to run. During that time, it would pick a random node to shut down. And if it had an effect on one of the services, they'd go back and make those services more redundant. It's kind of a, blunt weapon approach, but, it turned them into the company they are today. So at least some part of it worked. Very straightforward, but also very disruptive. A lot of the teams didn't have forewarning, so the shutdown kind of came as a shock, but that shock is what made them increase their services. The problem is that, of course, once that experiment starts, there's really no going back. There's no way that you can stop that shutdown command once it's issued in case you want to, reschedule for a different time or you submitted the experiment by accident. And if you're not sure whether your systems can recover, it probably won't be a good time. Now, option two is to run a black hole experiment. And this is the option we recommend because it has the exact same effect as shutting a node down, right? You're making that node inaccessible to other nodes in the cluster or to traffic on the internet. But the difference with black hole is that because it's working on the network, You can fine tune it to only block specific kinds of traffic, and you can stop it at any time. And when you do, your node will immediately start communicating with the rest of the cluster again. Right? We're not actually taking down network interfaces or even setting firewall rules. We're just blocking the traffic as it comes in. So as soon as that experiment stops, traffic continues to flow and systems return back to normal. So how could we actually do this? Well, like with scalability, we can create an experiment in Gremlin and simply choose black hole as the experiment type. One really nice feature in Gremlin, I'll show a bit of this later, is that you can have it randomly pick a target out of a group when you run the experiments. So for example, you can select your entire cluster as a target, and even if that has 5 or 10 or however many nodes, you can specify it to only impact one of those nodes. Then when you go to run the experiment, Gremlin will pick one of these nodes at random, and that gives you a bit of that, unpredictability that Chaos Monkey is known for. It makes it so useful, but without, accidentally taking down production or blowing up a data center or whatever it might be. So just again, for redundancy, black hole is what we recommend using instead of shutdown to be able to test that redundancy. So with that, I'm going to hand it over to Dan, who's going to show an example of how this could work in practice.
Give me a second here. I'll start sharing. All right, so what I built is basically just what Andrew walked through. So we will talk a little bit about this. So I've got an auto scaling group set up. Right now it's just running one EC2 instance that is a T2 micro, just a small Linux server. So we've got that set up. I've got a monitor set up, so we're monitoring the health. Right now, of course, it's healthy because it's not really doing anything. So we can kick in a Gremlin test, and then we'll see if the monitors work, and we'll start to auto scale this. So there's a couple different ways we could do this. Since this is a VM, um, easy enough to do it through the Gremlin UI. So I'll show this real quick, and then we'll actually kick this off from the command line on the instance itself. So if we look at it, the experiments here, the agents. Here's the agent. This is the T2 Micro. It's a Amazon Linux box that I built. So from here, I can just run an experiment on this host. So that host is automatically selected because of how I went into it. I will choose a gremlin. So, this is where, depending on if you're wanting to test that redundancy or the scalability, you can run the different types of experiments. So, we'll run a CPU experiment today. So we'll configure that. So you can configure how long you run it, what capacity, how many cores you want to impact as well. Just to cover it while we're here, the black hole attacks that Andre was talking about, we'll be able to configure from here. So we could select a black hole experiment as well and run that, validate, make sure those load balancers are working correctly. So to do this, I thought we always run the experiments from the Gremlin UI. That's where a lot of people do it, but not everybody knows that you can do this from the command line as well. So I basically just used uh, just the Cloud Shell to the box. This is the IP, the 172.32 to 170. So basically, I'm just going to run this command. So it's going to be a Gremlin attack CPU on all cores, 90%, and run that for 600 seconds. And then I'm going to throw that in the background so we can kind of look at it as it starts running. So we will kick this off, and assuming it's still active here. All right, let's try this again. Let's copy and paste that. There we go. All right, so that is running. And so by putting that in the background, it allows us to continue to look. So that is going to be kicking off anytime. So if we look at just a simple top command on this box, we'll see right away the gremlin running the CPU test, and we'll see it floating around that 90% mark. So we'll see that bounce around from 89s to low 90s. So we'll see that work. Um, so real quick, I can pull over and see. It takes about 2 or 3 minutes usually for the alert to actually trigger because of the timing threshold for AWS. But we should see this start to scale here relatively quickly. So, in fact, let's look at the alert. So yeah, so the alert's in an alarm state right now. So it's received the alerts. I did change this. The default is like 5 minutes. I changed this to be a 10-second polling interval just to try to speed this up a little bit so we could take a look at this. But if I go back, look at my auto scaling, refresh, and we can see now I do in fact have another EC2 instance that is pending. So this one is coming up, it'll be added. And of course, if the test continues to run, it will continue to scale up based on the settings for the scaling group. Just to kind of confirm this, right, if we look at um, the activity for my auto scaling group, we'll see basically just a minute ago, got to launch a new EC2 instance. So this shows basically that the monitor alarm CPU was exceeded, and so we're launching additional capacity to handle the load. So we'll see the increase in capacity from 1 to 2. And again, if I leave this running for I think it's 5 minutes, 6 minutes. It'll go ahead and it would scale and add an additional one, take it from 2 to 3. And then on the flip side of that, if you configure the scale in policies, once the test is done, those EC2 instances will scale back down to the original desired state. Any questions or anything from there? Andre, I think that was it from the demo point of view.
Cool. Yeah, thanks, Dan. I just see a question pop up in chat is, can this type of testing be performed without any added coding or tagging AWS? And the answer is yes. Gremlin pulls in a lot of
Mhm.
AWS tags automatically, like cluster name, instance name, image name, a bunch of others too. So you should be able to see those pop up when you add the Gremlin agent to your node. And let me just
Yeah, and you can definitely use it. I mean, you can do it by IP address. You can do it by, you can even do custom tags from like the Gremlin agent standpoint. So you're able to, add tags to Gremlin if you need to make it a little bit easier to do targeting. But yeah, you can definitely do this without definitely no coding. Tags are relatively easy, but we pull in the tags that are already in AWS, and you can use those. So zone failure is a good one that we use the zone tag that's put in by AWS to target that and recreate that.
Yep. And if you want to, you can add your own custom tags. We support those too. All right. Before we wrapped up and switch over to Q&A, I just wanted to cover one more quick topic. We hear this a lot is, what do you do once you've run your experiments and fix any issues you find? And the answer that we go with is to automate. You want to be able to repeat these tests frequently. We recommend once per week if possible. And the reason is that, unsurprisingly, systems change over time, right? People deploy new code, changes, or you might make changes to your infrastructure, to your observability and alerts. And of course, your cloud provider will be constantly changing and tweaking their systems behind the scenes. Might not be in ways that you notice or directly impact you, but they could still have effects on your services. This can also lead to regressions, which are, of course, problems that were supposedly fixed in the past, but crept back unexpectedly. So we really recommend that once you get these experiments, once you're comfortable with them, start automating them so they run regularly. And Grumman has two main ways of approaching this. First is creating a scenario with your experiments that you want to run, then scheduling it to run at least once a week. If you're not familiar, scenarios are basically workflows that you can use to run multiple experiments, either sequentially or in parallel or both. They also support health checks, so you can monitor your systems while you're testing them, which we really, really encourage. The second approach, which is what you're seeing in the screenshot, is to use reliability management test suites. If you're not familiar with those, a test suite is basically a collection of scenarios that you can run on your services. And in Gremlin, the service just represents the systems that you want to test. So in this case, we could have an application that we're running in this ASG, or even the ASG itself. Like a great thing about services and test suites is that you only need to define them once, and you can schedule tests to run on them weekly, just like with scenarios, as many as you want, and we just make it a lot easier to do that. But it does require some additional setup. So if you want just an easy, fast, direct way to do it, creating and scheduling a scenario is the way to go. All right, so we are going to open it up for questions. In the meantime, or if you're interested in getting started, there are two ways that we offer. First, jump in the product, give it a shot. If you're a current customer, you should already have access. And if not, you can get a free trial at gremlin.com/trial. And like I mentioned earlier, we do have upcoming office hour sessions. So if you'd like to register for more, you can do that at gremlin.com/office hours. So let's see if we have any questions coming through. Okay, so we have a question that was already answered, which is great to see. This can be done in AWS EKS, but not serverless configurations. Like Anantha said, we have failure flags, which is a relatively new feature that we released that lets you run potentially chaos engineering experiments within applications directly. So we have libraries for Node.js, Go, Java, and Python. You integrate those libraries into your application code, and you can trigger experiments in that code just like you would for any infrastructure or Kubernetes cluster. Right now, we support injecting latency, so you can delay the code execution by a second or 2 seconds or however many milliseconds. We're able to inject exceptions as well, or errors rather. And we also allow you to inject your own custom behaviors too. So let's say you want to log your experiments. You can add a logging statement that only triggers when you run an experiment. And just like with our infrastructure experiments, we make it really easy to see what ones are actively running. We give you the ability to stop them immediately. And if you don't have any experiments, the libraries have no performance impact on your code. So we try to make it as non-intrusive as possible and as easy to fall back as possible. And yes, we do have a Lambda layer, and we also have a container sidecar, I believe, that you can use to run in Kubernetes or Docker. Thank you for that question and also that answer.
Andre, is that a topic for a future office hours?
I think
I
so,
don't
but
remember off the top of my head.
that's a
So
good
if it's
question.
not, it's something that we should probably look at adding and maybe see if we can get Jeff to come on and talk about it and demo it for us.
Definitely. Any other
But any other
question?
questions that we can take care of while we're here?
Sure, I can try to specify how easy it is to integrate and use. Uh, Honestly, the probably best resource for that would be the link that Dan provided. We also have a few tutorials that we've released. I'll see if I can pull them up so I can paste the link in here. Basically, they just run through how to actually implement this in an actual um, uh, application running on AWS Lambda. So I'll see if I can change my screen share real quick. Let's see. All right, so what you're seeing here, besides my ugly mug, is a tutorial that we released on using failure flags on Lambda with Go or Golang. And essentially, the way it works is, you pull down your library, you have a Go application rather. You include the Gremlin's failure flags library. It's just a simple line. And then within your main code or wherever you want to actually implement the experiment, you would implement what is called a handle request. And essentially what this does is, well, rather, sorry, not a handle request. That's the function that Lambda calls. It's this gremlin invoke line. And you'll see it's followed by gremlin.failure flag. What this does is it basically creates a marker within your application that says, here's a place where we can inject fault. So we can give it a name. In this case, I just called it HTTP ingress-go, just to identify it as, HTTP application running with Go. You can also specify custom labels. These labels help you fine-tune what traffic the experiment is impacting. So like if you wanted to only impact requests that use a certain HTTP method, you can pass in the method. Or if you only wanted to impact a certain like HTTP path, you could input the path too. And you can, of course, have your own custom labels and variables here as well. And then there's also the ability to include certain behaviors. This example doesn't have it, but if you wanted to, again, like I mentioned earlier, add a locking function or an exit path or something while an experiment is running, you could add them here as well. And the second step besides that, of course, you would bundle your Go application like normal and upload it to Lambda like normal. Um, You would also include your client configuration file so that it can authenticate with Gremlin the same way that you would with an agent or Kubernetes container. And then we offer what's called a Lambda layer. So this is an additional layer that you put onto any Lambda applications that you want to use failure flags with. We have a bunch for all different regions and architecture types. So we support x86 and also ARM. So you would include this ARN, and we have a link to them as well from here too. You just include that ARN, add that layer, and then you should see the failure flag pop up within the Gremlin web application. I don't have any of these running anymore, so unfortunately I can't show you what it looks like in the app, but it's very similar to how you'd run an experiment on a host or a Kubernetes container. So if you want a link to that, I'll post that in the chat, and that also links out to other tutorials too. I can definitely understand you get pushback from developers who don't want to add CAS specific code to their projects. Totally understandable. That's actually one of the mindsets that we went into developing with this. Sorry, we went into developing this with that mindset of, frankly, experiments are scary. Folks don't want to put a place in their code where they think other people might introduce faults. So that's why we're really focused on making this as safe as possible. That's why when you don't have an experiment running, none of this code runs, right? We basically just keep running the application like normal. We try to keep the performance impact to 0 because we know those CPU cycles are precious on serverless platforms. So unless somebody has the ability and has the permissions to go into Gremlin and run an experiment on this specific failure flag, nothing will happen. There's no way that somebody can cause any impact otherwise. So hopefully that gives them a little bit of a better sense of safety and a better sense of control over that. But I mean, we get it. We've worked with a lot of teams who are hesitant about this. So that's why we try to approach it this way.
Yeah, and kind of to add to that thought a little bit, Michael, it's very similar to failure flag or to feature flags. So if they're used to using feature flags, this should be, very similar. Um, and even though it's in your code, there's 5, 6 different options that have to really be set before it would ever be able to do anything. So you have to have access to the Gremlin control plane. You have to have it enabled. You have to have it configured inside of Gremlin. So there's several different layers. So it actually takes a decent amount of effort to make it work. So if any of those failed, then the entire thing goes into basically no op and has no impact. So it is relatively safe to do. So typically, once they kind of understand that, sometimes that can help with the pushback a little bit. But it is safe to run and leave into your code even in production.
Okay, I actually do have some examples I can share. So let me see if I can pull this up. Sorry, these are actually the ones that I used for this tutorial. The failure flags get listed here. This is one other feature that I should have mentioned is that you can mark them as protected as well. So if you don't want somebody going in and running experiments on this, you can come in, mark it as protected. It'll be excluded from future experiments. And so that no op that Dan was mentioning will happen if anyone tries to run an experiment on it. It'll also show up as protected here, so you can't even create an experiment if you wanted to. But essentially, the way this page works is that once you have your Lambda up and running, it'll show up here under services. Each of those Lambdas can have multiple different failure flags within them. So you saw I had the HTTP ingress go. Maybe in another method, I can add another failure flag that's called something different or that does some other different behavior. So that would show up here as well. And then for each of the experiments that you actually define and run, like the latency or the exceptions, those will show up here after you run them. So you can rerun them if you want to. You can see when they were last run, and so on. So if I wanted to create a new experiment to run on it, I'd go up to experiments, I'd give it a name, I'd select which failure flag I wanted, just select which service I wanted to run it on. The experiments here are a little different because the way we package them is as JSON. At the moment, it's not point and click like the other ones, but we're working on streamlining this interface a bit more. So you would come in here and you would add your experiment parameters, like for example, say latency 1000 for 1 millisecond, or rather that would go into effects. Sorry, attributes are what you would use to fine tune what types of traffic would be targeted. So using those labels. And you come down here and you specify the probability, which is essentially the percentage of traffic that would be impacted by this experiment. 100% obviously is all of it. Or if you only want to do half, you could do 50. And choosing how long you want it to run. 5 minutes is a good average. And then you would click save and run. But I'm just not going to do it this time. So that was a really quick, really fast look at how Ferial Flags works. Again, thanks so much for joining us for today. Hope this office hours was helpful. Again, if you want to see the tutorials, Ryan posted a link a few posts above. It's just grumman.com/community/tutorials. You can also go to grumman.com/resources, and that will open up pretty much all of the content that we have on our website to you. So if you have questions about a particular topic or a particular platform, that's another great place to look. In the meantime, if you have any more questions, feel free to reach out to us. We're always happy to talk to folks. And definitely check out grumman.com/office hours for our future sessions. So in the meantime, thanks again for joining and have a great week.